Hello. Sorry, I had some problem with the stream. Should be good now. We'll have some time to wait for some people to come in. About 2 minutes, I'd say. I'll send out an email. Hello. Ooh. Hello. Oh, it'll take about 1 or 2 minutes for people to come in. There was some problem with the stream. Hello, hello. All right. We'll wait 30 more seconds. I'm sorry about the late start. There was some problem starting the stream. So if you haven't gotten this one already, so please go get it. If you already have it, grab a drink or I don't know, grab something to eat. We'll start in about 30 seconds. All right, 30 seconds. All right, good morning. Let's get started. Yeah. So today we're going to talk about area. Primarily, we're going to review area of a circle, and we're going to focus on area of a regular polygon. That's the main focus. All right. So here I'll just write calculate area of a regular polygon. Okay. Today's date is 30th. Okay. All right. So, first of all, let's review real quick. They're parallelogram, triangle, and trapezoid. These are commonly seen polygons that we learned before about their area, which is called base times height for parallelogram, 1/2 base times height for the triangle, and 1/2 b1 plus b2 times height divided by 2. This is just review, right? Any questions about these? Okay. All right. So before we start talking about regular polygons, I want to talk about circles. So I'm going to show you why circle area is pi r squared through some informal proof, but I mean it's kind of formal. It's not like step-by-step formal. So if you look at this, this is a circle, right? What is the definition of pi? What is pi? Well, pi I know by definition is approximately what, 3.14 something, right? But what is the meaning of that? Anybody know? What is the meaning of pi? It's the area of half a circle with a radius 1. It's not an area, but good try. Perimeter. Circumference, maybe. I think you're right, but the more literal meaning is it's the ratio between the diameter, circumference and diameter. Okay, circumference and diameter. What that means is that how many diameters I have in a circumference. Okay, so like how many, like if I take CD, right, I make it a string and I go around the circumference, how many diameters can I fit within CD? Okay, that's basically the idea. Okay, so because of that, I know sorry, 2r. I know d is 2r, right? So 2 times radius, diameter is 2 times radius. So then if you rearrange it, you know the circumference should be equal to pi times diameter, or 2 pi r. We're okay with that? That is a familiar equation that we have been using. Okay with that? All right. So, that being the case, let's take a look at how is that related to area of a circle. Okay. So take a look. So before we start talking about area of a circle, let's talk about a area addition postulate, which is basically saying that if I want to get the whole circle, then I can do separate, cut them in parts and add them up, and there will be so area of a region is equal to sum of the parts, non-overlapping parts, which makes sense, right? So since I know that circumference is 2 pi r, right? What is 2 pi r? Is pi r plus pi r, right? There are two parts of the length. So in other words, if I cut in the middle, then one side is pi r, the other side is also pi r. Do you agree? If I cut it in half? If I cut this in half, right? Cut it in half, then one length on the side is pi r, half the circumference, right? The other side is pi r. And then I'm gonna rearrange them and stagger them like this. One up, one down, one up, one down, like this. Then, in other words, this part should be pi r, and this part should be pi r, right? What does this shape remind you of? What is it similar to? What kind of shape? Or what kind of polygon? Parallelogram. Thank you, Kian. Thank you, Sia. Thank you. So, parallelogram, right? It's similar to that, but it's not exactly because this is all curved, right? So, we could, at this point, approximate the area by base times height, but it's not convincing. So what we do instead is we cut into more pieces, right? So if we cut into more pieces, it's pi r and pi r again, right? If you cut into more pieces, do you realize that this part getting straighter and straighter? And this radius is getting more and more closer to the height of the parallelogram. Okay, so if you do that infinitely many pieces, like you do many pieces, if that's the case, then eventually this will flatten out, because the smaller it goes, the more the sector will look like a triangle, right? So the area of a circle should be ending up with area equals base times height, right? So pi r times r, which ended up being pi r squared, which is the formula we know and love. Isn't geometry a magical thing? How do we feel? This is just a quick recap on how one of the ways to look at area of a circle. How does that even work? You mean like, why does it make sense? Or so let's look at kind of like an example. So if you look at, like, you know how like we had a sector before and we have a triangle, right? So exactly, each piece still have a slight arc, but the arc slowly get flattened, right? So for example, if the difference between this one versus this, right? If you're smaller, then the arc is slightly straighter, right? Imagine this angle, right? So if you look at two different angles, right? This angle is smaller than that one, so this is slightly flatter. Imagine this theta being infinitely small, smaller than 1 degree, smaller than 0.1 degrees, smaller than, if this approaches to 0, approaches, okay, I didn't say equal to 0, approaches to 0, theoretically, these two should be approaching to each other, right? Because the smaller the two side the angle is, the closer the arc and the base of the triangle is, right? And eventually they should approach each other. Okay. So it's the grand idea of infinity. Okay. No, it's not never mind, parrot. You got a very good point. You know? Very good point. All right. So, let's flip it over. So now the interesting part is here. So here is the regular polygon. Why are we talking about circle first? Because we just talked about sector, area, and circle, right? If you have a regular polygon, the regular polygon can always be inscribed in a circle. Okay, I can draw a good circle afterwards, but it's inscribed. Okay, why does that work? Because you have, what does regular polygon mean? You have equal angular and equal lateral, right? Meaning that the sides are congruent and the angles are congruent. Okay, so each of these angles are congruent and each of these sides are congruent. Okay, so let's just put S on each one. Okay, side, 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 right? And our strategy, our strategy to find the area of a polygon is then, since they're all equal parts, let's cut them into triangles. Okay, in this case, Pentagon can cut 5 triangles, because however many sides you have, however many base you have for a triangle, and however many triangles you can cut. Okay, and then you just multiply by 5 in this case after you find the area of a triangle. Okay. All right. So, if you need an area of a triangle, so let's take this part out. Okay. You move it up, right? It looks like this, right? So, obviously there are 2 parts. One is called the radius. One is called the side length, right? So side length in this case will be in the bottom, and R will be, these 2 parts will be here and here, right? Do you agree? And then to find area, okay, and you have an angle here, right? To find an area, there are 2 approaches. Okay, one, you can find the height. You can find the height. The height here, we have a special name for it. We call it the apothem. Apothem is here. It only works in this case. Okay, so the apothem. So if you want to find the area of this, then it will be what? 1/2 S times A. At base times height. Or another way to look at it would be 1/2 AB sine C. Remember this formula? Is it here? 1/2 A times height. 1/2 AB sine C. Right? This is the other formula we had. 1/2 AB sine C. Right? 1/2 RR, so R square, right? RR sine theta. Okay. So these are 2 separate ways of looking at the area. They're both giving you the same answer, whatever is more convenient. Okay. If you have radius given, then you can use this one. If you have base given, usually it's easier to use this one. Okay. Regardless of which method you use, eventually you need to multiply by 5. Okay. So area of a whole polygon is either 5 times, in this case, this part depends on how many sides you have, okay? 1/2 SA, or n times, or in this case 5 times, 1/2 r squared sine theta. Now let me ask you this. In this theta case, what is theta? How do I calculate theta? How do I calculate the angle? Well, how many triangles do I have? How many triangles do I have? How many pieces do I need to cut this circle into? How many pieces do I need to cut this into? So, yeah, exactly. So you can cut into 5 pieces. So this degree should, this angle measure should be 360/5. Okay? In this case, it's 72. And whatever the radius is, the radius will go in. Okay? And these we'll find also. Now, notice one thing. If you look at the equation of the first one, right? What? Okay. So, if you look at the equation of the first one, you realize there's a 5 times s. 5s, right? Which part of 5s does it what does 5s represent, basically, in this polygon? What does 5s in this polygon represent? Perimeter. I think the amount size is kind of correct, but it's called perimeter, right? So in other words, these two can be combined as P, which can give you an alternative formula for area, which I basically never use, but it's okay. If you want to use it, it makes sense to use it, right? 1/2 A times perimeter, because that's just how the formula formulates. Okay. Any questions? All right. So let's take a look at the next part. All right, so let's take a look at a see if we can look at a particular problem here. So, what does heptagon mean? Heptagon has 7 sides, right? So 7. So that means I can cut the polygon into 7 pieces. It's not perfect, but you know, and 2 feet per side, right? They say. So I'm gonna grab one of these out. Okay. So it's gonna look like this. I don't know radius, so in this case I won't use radius. I'm gonna use this, okay? 2 base. Okay. So now we need to find the problem, right? Because we need to find the height. So to find the height, I'm gonna cut this in half. So 1 and 1. We're good with that because 2 cut in half, 1. Then what? So what is the angle that I get? Anybody tell me? What is the angle I would get? Isn't that, what, 360 divided by 7? Which is what? 51.42, right? So each one of them is 51.42, 51.42, 51.42, etc., right? All the way around. But I'm cutting it in half, right? And I'm trying to find the apothem. So what would the half of that angle be? What would half of that angle be? You gotta divide by 2 again, right? You gotta divide by 2 again. So what would that be? $50 25.71. Okay, so put that in here. Okay, 25.71. All right, so now what? I want to know this. I already know this. So what trig do I use to fix this? What trig function do I use? Tangent, right? Opposite over adjacent. So tangent 25.71 degrees is equal to 1 over a, right? Opposite over adjacent, right? So a will be, but you're going to give me a good answer. It's 1 over tangent 25.71, which is, what is your apothem? What do you guys get? I don't have answers right now. 0.49. No, that A is equal to 0.49. That can't be right. I need 1.532. 1.535? You sure? Isn't it? One divided by tangent 25.71. Got 2.07. 2.08. Okay? 2.08. If you get a different answer, it's possible that you're in radian mode instead of degree mode. We're in degrees, okay? Make sure you're in degrees when you're doing it. All right? Make sure you're in degree, because yesterday I was in radian too in one of the classes, and I also get 1.5 something, and I think it's wrong. All right, so you got apothem. So you have a triangle. In this case, will be 1/2. Base is 2 times height, which is 2.08. But how many of these triangles do you have? How many? 7, right? So 7. So you gotta multiply the whole thing by 7, which turns out to be 14 point. They say round to nearest tenth, right? So we just 14.5, and this is in feet square. Okay. Times 7. Everyone understand why I multiply by 7? Mm. Oh, it's because the apothem was also rounded. Here, let me show you guys what happened. I just directly multiplied it over, so I didn't round during the middle of the multiplication in the calculator. So that's why usually they ask you to round to the nearest. When they ask you to round to the nearest, you don't want to round during your calculation. Okay? Yeah. It's all good. It's just a habit that I have to avoid this kind of problem. Okay? All right. Flip. All right. So, ideally, yes, Dia. In the test or homework, it's usually just a habit to use. If you can use the calculator. It's just my habit. Okay. All right. Comfort level from 1 to 10 about this problem, this kind of problem, finding area of polygon. Give me a number, 1 to 10. Okay. 7 to 8 is not bad. So let's take some time to practice on this one, the 12gon. And I'll wrap it up once we're done. Meanwhile, can you guys type your here so we can take attendance real quick? Alex, are you here? Alex, if you're here, send me an email, right? I can't see your comments. Yeah. Other people, I think I got all of you. Tina? Yeah, I got Tina. Yeah. Everyone except for Alex, I think I got. Ryan, you don't have to yell at me, okay? Chill out with the caps. Yeah, Alex, if you're watching a video, send me an email about the video so I can fix your attendance. Other than that, I got everyone else. Okay? So, let's look at this. How far are we on this problem? I'll start doing some markings. So length is 5 each, right? Done. What do you get? Oh. Take out this triangle right here. What is, the base is 5, right? 12 root 3. I don't think it's 12 root 3. Is it 1? Or is it 12? Like whole thing. 112. Interesting. Let's take a look. Let's take a look. So we're here, right? You gotta first cut 44.2. Okay, we got too many different answers. Let's see. Oh, 249. Interesting. Alright, so let's cut it out. So if we cut this, I will get what? 360 divided by 12. So each one should be 30, right? But as we know before, we need to cut it again here because we want to find the apothem, right? Apothem is the height. So the height, A, apothem, this will be 15 then, right? 15 degrees. We got to cut it again, right? Lissa, I got you. I got you. So, then I will do tangent 15 degrees is equal to, if you cut it in half, 5 in half is 2.5 and 2.5, right? So then it will be 2.5 over A. So in other words, your area should be equal to 2.5 divided by tangent 15, which is this number, 9.3301. So I'll keep this 9.3301. Okay, I'll keep as many as I can. I'll keep it in my calculator, so when I multiply it through, it will work. Okay, so the area should be 1/2. Right. Keon, it's probably because you need to change your mode to degrees instead of radian, your calculator. So area should be 1/2 base 2. Not 2.5. Base is 5, right? 5. This is base 5. 5. Okay, 5. Base times height is this one, 9.3301, right? Base times height. And then you multiply by how many? 12, right? Because there are 12 of them. So I do times 0.5 times 5 times 12. There. 279.9. 0. Right. 279.9. 279.9. Forgot the apartment existed. Hilarious. All right. How are we doing? Good? So 279.9. Okay. So after this, what's our comfort level? 1 to 10. Give me something. Oh, this is centimeters, right? Centimeters square. Better, worse than, just put better or worse than the previous one when I ask. Good. So your homework is going to consist of this kind of problem. All right, there's some problem with some people doing homework. Okay, homework is on bigideas once again.com. Okay, make sure you have the login for this. Okay, I have some people who just haven't been doing homework. If you don't do homework, you will have a hard time passing the class or getting credit, because there's only a few ways to measure your achievement. Now we're in remote learning, okay? So I'm gonna put it straight up. Most of you do a good job. Some of you just haven't been doing work, all right? So bigideas.com 11.3 assignment is due this Sunday. Okay, make sure you finish it in time. Why? Because I cannot reopen it once it's overdue. Okay, I collected, I recorded grades, then that's it. All right, I cannot reopen it. So for the people who already missed it, the only way you can make up assignments, all right, make up. I need to post this here so that people will stop asking me, because I have a couple of people who want to make up. If you want to make up, you're going to do way more work. Okay, why? Make up each section. You need to do all even problems on paper. Okay, for each section to make up 90% of credit. Okay, say that again. If you want to make up your grade because you didn't do it, then you need to do all the even problems on each section on paper, 90%, and email me the picture. Okay? Email me pictures. This is way more work, like 2 to 3 times the amount of problems I usually assign. It depends on the section, obviously. This section is probably a little more. The previous section, like 11.1, 11.2, make sure you have that. Okay? All right. I know you guys care about the test a lot, so let me re-announce it. Chapter 10 test. Chapter 10 test consists of, it's going to be on Friday. Obviously, it's a non-class day. And it's going to start from 7:20 a.m. It's going to be open on that time, all the way to 11:59 p.m., which means you have the whole day to do 20 problems. Okay, so just pick your time and you do it. It's not timed. Well, it's timed for the whole day, but it's open notes, open book. You can do what you want with this one, and basically, yeah. Does that make sense? So you can basically catch up on, like, spend some time, make sure you remember how to do it. I would study first because you only get several tries, and it doesn't check your answer. I forgot if I put like 3 tries or something, or I think they don't let you check your answer. Like they don't check it for you. You have to click submit, once you click submit, then it's like a test, right? It's like a test, but you have a lot of time. It's great on accuracy. 20-point problems, 20 points on test. Okay, 20 points. So instead of 100 points like usual, it's gonna be 20 points. Because it's hard to keep track of people, so I'm not gonna make it as high stake, obviously, but you can have the whole day. It's individual tests, okay? It's not grouped. Obviously, there's no way. It's like normal. It's going to. No, okay. Next Friday, yeah. You can still change your answers freely until you turn it in. Parrot. To answer your question, it's the same thing as the normal test. You can freely change your answer until you click the submit button, like when you turn in the test at the very end. Okay, so it's very similar. Test is next Friday, Hannah. Next Friday. What grade do you get to get? So Sia it's the same thing. So it's gonna be incorporated in your old grade book because it's a whole letter grade, right? So it's gonna be taken into account as your old test grade. So it's gonna somehow affect your test grade, but it's not gonna affect it that much because it's like almost like a quiz grade. Any other questions before I let you go? Any other concerns? So should I just play the music and let you go? Let's do what's a good song? You guys still teenagers, right? This song's called Teenage Dream by Curtis Cole. It's non-copyrighted. That's why I'm playing it. Goodbye then. No problem.